let's push on and talk about the family of B vitamins. There are a lot of them, so get ready. Thiamine is the vitamin part of a coenzyme, which is known as thiamine pyrophosphate. That is going to assist in energy metabolism. That coenzyme is going to be important in converting pyruvate to acetyl-CoA. So thiamine plays roles in metabolism. It will also attach to a receptor site on membranes of neurons and their effectors, the cells that they communicate with. So that it's important for appropriate functioning of the nervous system. Muscles are also very heavily dependent on thiamine for normal functioning. The recommendations, in terms of dietary recommendations, are going to be based on thiamine's role in enzyme activity. So if you are eating enough food to meet your energy requirements, and you're getting that from nutritious food, generally you get enough thiamine. If you don't eat enough to meet your energy needs, you will actually risk nutritional deficiencies, including one for thiamine. The deficiency of this B vitamin is often reported along or amongst populations of malnourished as well as homeless people. Further, for those individuals who consume their calories mostly in the form of what are known as empty calorie foods or alcohol, you're likely to risk a thiamine deficiency. Take a look at that. About 4 out of 5 alcoholics are thiamine deficient, which can end up causing Wernicke-Korsakoff syndrome. And that, look at the symptoms: disorientation, or short-term memory, eye jerk, movements, also known as nystagmus, and staggering gait. Watch that video, it's kind of eye-opening. If you have a long-term deficiency in this vitamin, you can end up with what's known as beriberi. And there are 2 types. Wet beriberi is wasting, and you have edema, which is swelling due to retention of water, especially in your extremities. And dry is just muscle wasting. That just is in air quotes. You will damage your nervous system, your muscles, including your cardiac muscle. Great little video on beriberi. This was actually first seen in Asia because the custom of taking rice and polishing it grew. Rice provided virtually all of the energy intake in Asian countries. And the rice bran and the germ were really great sources of thiamine. So when you polish rice, it takes away part of rice that contains thiamine. So people became deficient. Large numbers of people became deficient. There are a number of different foods that will provide thiamine, but few are really good sources. So your best bet is to consume different servings of a variety of foods in order to meet your thiamine needs. Pork is high in thiamine. And when you are consuming grain products, make sure you're looking for whole grain or enriched products, and preferably whole grain. And that gives you the RDA. I'm not going to expect you to memorize that because you can always look it up. But if you take a look at the deficiencies, large heart, cardiac failure, weakness, apathy, poor short-term memory, confusion, anorexia, weight loss, none of those are good. And there are no known toxicity symptoms, at least in this point. Moving on to riboflavin. It also acts like a coenzyme, most noteworthy in release of energy from macromolecules in every single body cell. So the coenzyme forms are listed there. I'm not going to expect you to know those. This was a multi-part nutrition course, I would, but it's not. But both of those molecules are very important in cell metabolism, which is the generation of ATP. Same with thiamin's RDA. The RDA for this vitamin is basically based on its enzymatic function. And generally, we mostly meet or exceed our riboflavin recommendations. So there are there's no single disease that's associated with the deficiency of riboflavin. But the sort of generic problems can be inflammation of the membranes of your mouth, your skin, your eyes, as well as your GI tract. So your mucosa, your mucosal membranes can be inflamed. Greatest source comes from milk and other dairy products. We didn't evolve drinking cow milk. So I would look to liver, clams, feta cheese, eggs. Feta cheese, that's a dairy product. Or is it? And of course, everybody's favorite leafy green vegetables. So if you're eating spinach or eating broccoli, those are great sources. B3, also known as niacin, also known as nicotic acid, nicotinamide, niacinamide, etc. Just known as niacin or B3. The precursor to this is the amino acid tryptophan. So that's pretty cool. It is unique when compared to the other Bs because the body can synthesize it from that amino acid. You can actually synthesize appropriate amounts of niacin. To make 1 milligram of niacin requires 60 milligrams of tryptophan. And then that shows you recommended intakes there. Again, so you can always look that up, so I'm not going to hold you responsible for that. If you are deficient in niacin, you may end up with pellagra, and this can kill you. It's the 4 Ds of pellagra: diarrhea, dermatitis, dementia, and death. So back in the early 1900s, pellagra caused well over 80,000 deaths in the South because people were they were eating a low protein diet based on corn. People didn't get enough niacin or tryptophan, so they couldn't make the niacin because at least 70% of the niacin that you find in corn is going to be attached to fiber and small peptides, which makes it unavailable for human digestion or absorption, which makes it have very low bioavailability. There's that word again. Corn is also going to contain leucine, which is an amino acid, which is actually going to interfere with that conversion of tryptophan to niacin. So double whammy there. It was pellagra itself was first thought to be caused or transmitted as an infection. And then took a little bit of research, but they found out it was just basically that people were deficient in niacin. And at the time, that was quite a unique discovery. It was an eye-opener for many, many researchers and scientists and doctors. So what about toxicity? If you are consuming niacin that you find naturally in food, no harm. Large doses, if you're consuming large doses from supplements, you can have a whole bunch of adverse effects, including what's known as niacin flush. So if you're consuming too much nicotinic acid, you will have dilated capillaries and you will have a really tingling, nasty sensation that can be painful and you will turn red. Hence niacin flush. Under a doctor's care, large doses of nicotinic acid have been used to reduce blood cholesterol levels. Notice that I said under a doctor's care, under physician's care. Any nutritional work that you do needs to be closely monitored with someone who knows what they're doing, because there are possible side effects which can have long-term effects. In other words, you can damage your liver, for example. So if you have liver disease or diabetes, ulcers, gout, heart conditions, migraine, headaches, you are particularly susceptible to any sort of niacin toxicity. There are the food sources. Let's move on to biotin. It's also going to be a coenzyme. It's going to carry activated carbon dioxide. And that's going to be important in terms of cellular metabolism and production of ATP. You need this in really tiny amounts. So an adequate intake level has been determined. And if you look at that micrograms, it's tiny. You're rarely deficient in biotin. And the problem can be if you're eating a lot of eggs. Sometimes people take the yolks out because they're afraid of cholesterol and they eat egg whites, but there is a protein in egg whites that will bind to biotin and will prevent its absorption if you're eating it in large amounts. Again, this is another B vitamin that's in various foods, so it's kind of hard to be deficient. It can also be synthesized by the GI tract bacteria, your normal flora of your large intestine. But scientists are really not sure about how much of that is absorbed and utilized for physiological reactions. Pantothenic acid has multiple functions. It's going to be involved in building lipids. It's going to be used as part of neurotransmitters, a component of neurotransmitters, as well as steroid hormones and hemoglobin. It is also part of coenzyme A in metabolic activities. So the AI for pantothenic acid is going to reflect how much we need to replace due to daily losses. And the AI for adults is about 5 mg per day. Deficiency, pretty rare. If you take a look at the symptoms, a general failure of most body organ systems includes fatigue, GI distress, and neurological disorders. Yeesh. But fortunately, deficiency is relatively rare. In World War II, there were prisoners of war in the Pac Rim countries who had what they termed the burning feet syndrome, which may have been caused by pantothenic acid deficiencies. People aren't absolutely sure about that. It's going to be found in a whole bunch of food. Dietary intakes generally provide adequate levels. There are the sources. This is important. It's that last couple of lines there. Losses of pantothenic acid during food production can be substantial. It is destroyed by packaging and some refining processes. So if you are a fan of highly processed foods, make sure you're eating various foods in order to get sufficient amounts of pantothenic acid. B6 has 3 different forms: pyridoxal, pyridoxine, and pyridoxamine, just no B6. All of those forms can be converted into an enzyme that is going to be required for metabolism of amino acids. It will also help function in transferring those amino groups when our liver is synthesizing non-essential amino acids. So it's going to be important. This guy is going to be important. They all are, but this one is important. Particularly important. So you have these coenzymes that are going to play a whole bunch of different roles in the metabolism of amino acids. Because of that, the previous RDAs were based on a level of protein intakes, but they've been changed. So there are the RDAs for adults. And there is an upper RDA, an upper limit, or an upper level for vitamin B6. If you look at the RDA, the daily RDA versus the upper RDA, huge difference. Now, let's talk about deficiencies. If you don't have enough, you can't make certain really important neurotransmitters. You're going to have these abnormal compounds that are produced during the metabolism of tryptophan. They may accumulate in the central nervous system, mainly in your brain. B6 deficiency is associated with depression and with confusion. May also trigger abnormal brainwave patterns and convulsions, and you might end up dead with more advanced symptoms. Toxicity, first report of this is happened in 83. Before that, researchers thought you can't reach toxic concentrations. In these people back in 83, they actually had neurological damage because they'd been taking a lot of it, 20 times the current upper limit for 60 plus days. Yeesh. All things in moderation. I bet you've heard me say that before. Now, some people, some women use B6 supplements to help treat PMS symptoms. Kind of sort of looks that it's more detrimental than good in treating PMS. So be forewarned. There's a food sources. Remember this, high levels of heat when you're cooking or when the food is being processed can damage B6 and it won't be functional. Folate, also known as folacin or folic acid. Pteroglutamate acid. Wow. It is a coenzyme, and it's going to be important. Once again, it's going to be important in terms of aiding and assisting metabolism. It's going to convert B12 to a coenzyme form and also help synthesize DNA required for all of the developing cells. And this is why it's super important that pregnant women have sufficient amounts of folate. So there's the recommendation, because the bioavailability, and in English that would be bioavailability, ranges from about 50% in foods to 100% for supplements when you consume them on an empty stomach. We're talking good supplements. So this is one vitamin that is more bioavailable when it's in supplement form. This is why this vitamin is so incredibly important. The fetal brain and the spinal cord, fetal spinal cord, develop from what's known as the neural tube. Deficiency in folic acid is directly related to defects in the normal formation of that neural tube. You'll hear neural tube defects. That's what they're talking about. They're talking about that the brain and the spinal cord do not develop appropriately. So you may end up with a raft of potential central nervous system disorders. It's super important that you consume folate in order to reduce risks of neural tube birth defects. That's a good video there. So a lot of the grain products that you consume have been fortified with folate because of the fact that folate does play a pretty important role in defending against cardiovascular disease, because one of its functions is to break down homocysteine. Without folate, homocysteine will accumulate, which can trigger blood clot formation and the deterioration of your arterial walls. Folate also may help prevent cancer, especially for people who are at higher risk because of genetics or lifestyle. Deficiencies of folate can really affect cell division, which should make sense if you're talking about neural tube deficiencies. Protein synthesis processes can be affected, Both of those are hugely important relative to growing and repairing and replacing tissues. And those are the symptomatologies that are associated with folate deficiency: megaloblastic anemia, smooth red tongue, because the cells of your tongue are wearing off faster than they can be replaced; feeling foggy and mentally confused, being weak, being exhausted or fatigued, being cranky, and having headaches. There are the food sources. You're going to see a lot of leafy green vegetables and a lot of legumes and beans throughout all this vitamin section and the mineral section too. Remember that folate is one of those B vitamins, and B vitamins are often easily destroyed by heat and exposure to oxygen. This is fascinating. Folic acid deficiency can affect the health of your great-great-grandchildren. Yes, it can. Watch that video. B12. B12 and folate are pretty closely related. They need to be together in order for activation of vitamins. Think back to our time when we went over anatomy a zillion years ago. You know that the stomach is going to produce hydrochloric acid. It will also produce the inactive form of an enzyme which is known as pepsinogen, which is activated into pepsin by that acid. You need pepsin in order to help release B12 from the proteins that it is attached to in foods. You also need intrinsic factor, which is a molecule that is produced in the stomach. So what happens is B12 attaches to intrinsic factor, and then that complex moves into the small intestine along with the chyme and is absorbed through the intestinal walls into the circulatory system. The RDA for B12, not very big, it's just micrograms, 2.4. I love this. A tiny amount contains billions of molecules of B12. And that's plenty, more than enough to provide all the coenzymes you need for the metabolism in your cells throughout your body. If you're deficient, it's oftentimes caused by inadequate absorption and not your ability to consume enough. Inadequate absorption is associated with either a lack of hydrochloric acid or a lack of intrinsic factor, or both. Without stomach acid, you can't release B12 from those proteins. Without intrinsic factor, you cannot get B12 absorbed into the intestinal linings of the small intestine. So when it comes to deficiencies, if you're over 60, you may end up with atrophic gastritis, which apparently is pretty common. It's going to reduce the ability for the stomach to produce both hydrochloric acid and intrinsic factor. That is triggering a condition called pernicious anemia. You also may inherit a defective gene for synthesizing intrinsic factor. And basically, just what that means is that patients will require B12 injections or use a nasal inhaler. We recycle B12. And because of that, it takes really a fair amount of time before somebody becomes deficient. And oftentimes I get students ask, well, how long? It's going to depend entirely on the individual. But take a look at this. People who have a prolonged decrease of intake of B12 may take up to 3 years before they develop deficiencies and become symptomatic because we recycle it. And that would be good to watch, 5 signs and symptoms of B12 deficiency. We've already mentioned that you need B12 to convert folate into its active form. So if you don't have B12, or if you can't absorb it, you're going to end up with an anemia, which is associated with folate deficiency. typically in this type of anemia, you're going to see these sort of large immature red blood cells, which are telling you that there's very slow DNA synthesis. The cells cannot divide properly and mature normally because of that slow DNA synthesis. Red blood cells are pretty heavily dependent on B12 and folate. So if there's a deficiency, those are the ones that will be affected most commonly or fastest. B12 or folate will clear up the anemia, but if you give folate when you need B12, you might actually end up with severe neurological symptoms. Giving folate when you need B12 can hide B12 anemia symptoms, but those detrimental neurological symptoms will still happen. What are those? Advancing paralysis begins in your extremities and works inward medially up to your spine. It's quite scary. You need to have this diagnosed relatively early, and you need to treat it quickly in order to prevent having permanent damage to your nerves and potentially paralysis. If you have sufficient folate in the diet and you have insufficient B12, you might end up with those neuro symptoms without any evidence of anemia. Those are the sources. Unlike most of the other water-soluble vitamins, your Nuker destroys B12 because it is small and relatively easily damaged. And to date, there have been no toxicity levels that are known relative to B12. We will move on to the next water-soluble vitamins in the next section. See you there.